5 today, right? Okay. Now, in the previous class, we have discussed that when we have different kinds of numbers, like 3 cases I discussed, when both the numbers are rational, right? So we were actually discussing operations on real numbers. Real means rational plus irrational. So there can be different cases. It can be, so I'm considering only 2 numbers. It can be more than 2, but right now let us take 2. So if both the numbers are rational, so either you do addition, subtraction, multiplication, division, or all any operation, you get a rational number. All right. Then if both the numbers are irrational and then you are doing operations, so it's not necessary that you get an irrational number. Okay. You can get irrational or rational, both. So that was the case. And the third case, when one number is rational, right? And the other is irrational. Understood?
Yes.
So one number is rational, other is irrational. In that case, you always get an irrational number. Okay, so this is the important thing. Please remember this thing. This will help you in the exercise now. Now, before proceeding with the exercise, just try to learn one more thing. When you have something like this, for example, inside under root, this is an identity, you can call it. So, for example, 2 numbers inside the square root. So you can break the square root. You can write it as under root A multiplied by under root B. Okay. It can be written like this. And similarly, if you have a fraction like A upon B whole square root, so again, you can write it as under root A divided by under root B. So these are the 2 identities you have to remember. Now let us come to exercise 1.5. Sorry, 1.5. Please open your book, all of you. Classify the following numbers as rational or irrational, right? First question, first part. So 2 minus under root 5, right? Okay.
Yes.
Now let us see what kind of number is it. So let us break it into 2 parts. Now here we have one number 2, which is what? Which is rational because it can be written as 2 by 1, right? Which is of the form of P by Q, where Q is not equals to 0, right? So that means it is rational number. Understood? Okay. Now we have under root 5. Now under root 5, so you have to take under root, right? So let us take under root 5 and see what value I get. So I told you how to take square root, right?
Yes.
So 5.000000 you can take. So let us start with 2 into 2, 4, right? So 2 into 2, 4. So I get remainder 1. So now this 2 multiply by 2, like 4. And then bring 2 zeros. Sorry, now, wait. Now remainder is 1, right?
Yes.
So you have to put a decimal and then you bring 2 zeros, right? After putting a decimal here. So it is 100. So I think 45 into 45 is 90, right? So I can do 45 into 5 will be, I think, greater than 5 into 5 is 25.
2025.
Oh, I'm getting quite large number. So if I do 42 into 2, 2 and 84, I think this will go, right? So 42 into 2 will be 84. So 10 minus 4 is 6. Then you have 9 minus 8 is 1. 16 remainder. Again, bring 2 zeros. Now you multiply this. So 2 into 2, 4. 2 into 2, 4. 44. Now what should come here? That is around 1600. Let us try 3. 4, 4, 3. 3 into 3, 9. 3 into 4, 12. 3 into 4, 12 and 113.
1329.
I think this will go, right? It is quite close to 1600. So 3 into 3, This is 1, 3, 2, 9. 10 minus 9 is 1. Then you have 9 minus 2 is 7. Then 5 minus 3 is 2. Yeah, so this was fine. Now again 2, 0 will come. And then you have to multiply this whole thing by 2. So 2 into 3 is 6. 2 into 2, 4. 2 into 2, 4. Now, let us try 5 times, right? So I'm just doing here. So 4, 4, 6 into 5. 25. 5 into 6, 30. 32. 4, 20 and 23. 22. I think let us check 6 also. 4, 4, 6, 6. 6 into 6, 36. 36 and 3, 39. 24. 24, 25, 27, then 2, 24, and 26. Yeah, this is even less, right? So 6 times will go. So 6 into 6. And then I have 2, 6, 7, 9, 6. Okay, then some remainder. And actually, this will keep on going, right?
Yes.
Okay. So my under root 5 is actually equal to 2.236 and so on. So what it is non-terminating. Yes, Jaslyn?
Non-recurring.
Yeah, and non-recurring also. So this we know such types of number are irrational, right?
Yes.
So now one number is rational, another number is irrational. So what should I get?
Irrational.
Irrational. Now rational minus irrational. It actually gives you an irrational number. So therefore 2 minus under root 5 is irrational. Any problem, anyone?
No.
Okay. So I hope you have written. Let's move to question number 2. Right. Okay. Second part. Please let me know if you have not written. Now, second part is 3 plus under root 23 and minus under root 23. So you have to see whether rational or irrational. Now, this is if you remember associative property, like you have 3 numbers, right? For example, A plus B plus C. Understood? You are adding them. So it does not matter, like if you starting, you add A plus B and then you add C, right? The answer will be same as if you leave A and then first you add B plus C. Does it matter?
No.
No, this property is called associative property. I mean, you have learned it in your previous classes. So the same property we will apply here. So we will write it as like 3 plus under root 23 minus under root 23. So this operation I'm doing first, right? Now you can put a bracket only if you have a positive sign outside. If I have a negative sign, then the sign will change inside the bracket. This you know. Now under root 3 minus under root 3 is 0. So 3 plus 0. So I get 3, which I can write as 3 by 1, right? So this is now of the form P by Q, where Q is not equals to 0. So therefore, this number, that 3 plus under root 3 minus of under root 23 is what? Rational or irrational?
Rational.
Rational.
Yes.
Yes. Okay, third part now. So third part is 1 upon under root 2.
It is 2 upon under root 7.
Sorry. Oh, okay, I have done the fourth one. Right, so third part is 2 under root 7 and divided by 7 under root 7, right?
Yes.
Okay. So this can be written as 2 multiplied by under root 7, right? And this is actually 7 multiplied by under root 7. So under root 7 will cancel out, right? I mean, you are left with 2 by 7 only. Is that clear?
Yes.
So this is of the form P by Q, where Q is not equals to 0. So therefore, 2 under root 7 divided by 7 under root 7 is rational. So basically, we are seeing that either you see some number in the form of P by Q. If it is in the form of P by Q, then you can say it is rational or irrational, or you look at the decimal representation, right? If you don't have the fraction form, then we go to decimal representation. And then we know that if it is terminating and recurring, it is rational, and it is non-terminating and non-recurring, then it is irrational. So both way you can identify. Now fourth part, it's 1 upon under root 2. Okay, who will tell me how to write it? Now 1, we know it is a rational number, right? But we don't know about under root 2. So we take under root 2 that we have already done in the last class. So tell me the value of under root 2. How much was it?
1.41 421.
421, and it will keep on going, right? So it is, you can write that it is non-terminating
Non-recurring.
and non-recurring. So it is like it is irrational, right? Okay. So basically 1 upon under root 2. So now you have a rational number divided by irrational number. So what kind of number I should get?
Irrational.
Irrational number. So this will actually give you irrational number. So when you can write, therefore 1 upon under root 2 is irrational. Right, Zeb, whose mic is on? Your voices are quite similar. Sometimes I don't identify. Okay, this was Zainab who was speaking, right?
No, ma'am.
Okay, so that was Zeba, I think. Yeah?
No, ma'am.
Okay. Jesslyn, were you speaking right now?
No, ma'am.
Okay, but please try to keep your mic unmute during the class so that we can have an interactive classroom, right?
Yes, ma'am.
It's not a good habit to keep the mic mute all the time. Right, next question is 2 pi. Okay, now 2 is, so basically now this is a product of a rational number, but let us first look what is pi. So pi,
22 by 7.
yeah, is actually 22 by 7, which we have calculated in previous classes also. You can perform the long division, who has not done it? Jesslyn, and so this is your homework, like if you have not performed it, so please carry out this division, understood? Right? So ultimately, like please do it and see yourself. Yeah, so you will get a number like this, 3.1415, and it will keep on going. Yeah, it is irrational. But actually try to show it, right? I just want you to do this division. So pi is actually 3.1415 dash dash dash. So this is again non-terminating and non-recurring decimal, right? So that means it is irrational, right? So now you have a product of rational number multiplied by irrational number. So what should I get now?
Irrational.
Irrational number. Okay. So therefore 2 into pi is irrational. Okay, next question now. Third. Now look at the third question. Oh, sorry, second question, not third. Second question, simplify each of the following expressions. Now, first part is this. 3 plus under root 3 into 2 plus under root 2. So now you will use actually distributive property. If you remember, let us just recall. For example, I have number A, right? And then I have a bracket B plus C. So basically A is multiplied with this bracket. So how do we break it? We break it like A into B plus A into C. Understood? Yes?
Yes.
All of you know this? Okay. So now,
Yes, ma'am.
okay. So now I have two numbers here in the first bracket. So first of all, I'm going to break the first bracket only. So I'll write it like this. So first I'll multiply 3 with this whole bracket, 2 plus under root 2. And whatever sign you have here, you put it here. Then under root 3 multiplied with the second bracket. Is that clear?
Yes.
Yes, ma'am.
Now carry on the division. So it is 3 into 2, right? Plus 3 into under root 2 plus then it is under root 3 into 2. You can put a multiplication in this step and plus, so under root 3 into under root 2, right? Okay. So 3 into 2 is 6 and plus, so 3 into root 2 will be simple 3 root 2, clear? Plus this is root 3 into 2 will be simply 2 into root 3, right? I mean 2 is outside square root, so it cannot go inside. Plus now I have just told you that if you have two numbers like this, so you can write them as 3 into 2, right? Clear?
Yes.
Okay. So it will be 6 plus 3 into root 2 plus 2 into root 3 plus under root 6. So can someone tell me like what is the answer given at the back of NCERT? Is this the answer or they have? Yeah, please.
Yes, that's the same answer.
Yes. Because you cannot do anything here, right? Now try to understand. This is under root 2 term, right? This is under root 3. You cannot add it. Under root 2 gives something else. Under root 3 gives something else. So they are different numbers. You have to leave it like this. Now second part. Now I have 3 plus under root 3 into 3 minus of under root 3. Okay. So it can be done both ways. First of all, you can do it like this. Again, 3, then multiply with the second bracket and then plus. So under root 3 multiply with the second bracket. Clear? Okay. Then it will be 3 into 3 and minus, so 3 into root 3, right? Plus again, root 3 into 3 will be 3 root 3. And then you have plus outside and minus inside. So plus and minus will become minus. So you have under root 3 into under root 3. Clear? Okay. So 3 into 3 is 9. Now you see minus of 3 root 3 and plus of 3 root 3. They both are same. So answer will be 0, right?
Yes.
Okay. So these two terms basically vanish from here. The answer is 0. And then minus. So under root 3 into under root 3. What should you get here? 3, right? See, under root 3 into under root 3 can be written like this. 3 into 3. As I told you, you can take both the numbers inside the square root if both have square root. So it will be under root. See, now you're taking under root and you have 2, 3. So one pair you are getting. So that means only one will come outside. Does everybody know how to take square root like this? Yes, Jaslyn. Any confusion? Please tell me honestly. Zeba.
No, ma'am.
Zeba. Any
Yes, ma'am. No,
Okay.
I don't have anything. No, no.
Okay. So 9 minus 3 and it is equal to 6. Clear?
Yes.
Okay. Now the same question can also be done like this directly if you want to do it. If you remember this property that a square minus b square is equal to a plus b into a minus b. Do you remember it? This is an identity, right?
Yes, ma'am.
So you can make use of this identity also here. So you can see 3 plus under root 3, right? And then you have 3 minus of under root 3. So it is a plus b into a minus b kind of expression. So you can directly write a square minus b square. That means 3 square minus under root 3 square. Clear? So this is 9 minus under root 3 into under root 3 is again 3. So answer is 6. So both way you can. If you don't remember the identity, just multiply it. Okay, third part. This is under root 5 plus under root 2 whole square, right? So whenever you have a whole square of the bracket, you cannot do under root 5 square plus under root 2 square. Here you have to make use of this identity that a plus b whole square is equal to a square plus b square plus 2ab. Is that clear?
Yes, ma'am.
Yeah, so this way you will open this bracket. So that means, okay, let me do it here. So under root 5 plus under root 2 whole square, that means a square. So under root 5 whole square plus b square means under root 2 whole square plus 2ab. So 2 into a, that means under root 5 into b, that means under root 2. Clear? Okay. Now root 5 into root 5 is 5 plus root 2 into root 2 is 2 plus 2 into, so all you can do is you can write 5 into 2. That's it. So it is 5 plus 2 is 7 plus 2 under root 10. That's the answer. Now fourth part is under root 5 minus under root 2 and under root 5 plus under root 2. Again, it is a minus b into a plus b, right? So I can simply use this identity. So I can directly write under root 5 whole square and minus b square. That means under root 2 whole square. So 5 into 5, oh sorry, under root 5 into under root 5 is 5 minus root 2 into root 2 is 2. So answer is 3. Is this clear?
Yes.
Yes, ma'am.
Okay. Now third question. Now please try to understand. Please read all of you in your book. Now recall pi is defined as the ratio of circumference of a circle to its diameter. So basically this is the definition of pi, that pi is equal to c by d, right? Right? Okay. That is, this seems to contradict the fact that pi is irrational. So how would you resolve this contradiction? Now please try to understand. We already know that pi is irrational, right? We have seen it. Clear?
Yes, ma'am.
Okay. Now any number c, for example, c is any number. So ultimately c is rational here, right? And similarly, d is another number. It is also rational because c can be written as c by 1, d can be written as d by 1, right? It is the both. So separately, they both are rational. That's okay. But if we look at the ratio, so you write it like this, that c and d are rational, right? Okay. But the ratio, if we take the ratio C by D, what we are getting? We are getting pi, right? The ratio C by D is actually equal to pi, which we know that it is irrational, right? That means C and D both cannot be rational. Understood? So there's a contradiction. Getting the point? Okay, go back to that section. When I told you that if we have two numbers, right? One is rational, another is irrational, and we do the division. If I have, for example, rational upon irrational, what should I get?
Rational.
Irrational. In all the cases, I'm going to get an irrational number, right? When one number is rational and another is irrational. So you perform any operation, addition, subtraction, multiplication, division, you always get an irrational number. Even the reverse, like if the numerator is irrational, for example, and the denominator is rational, then also like one number is rational, another is irrational. So it will give me an irrational number. Understood? So,
Yes, ma'am.
okay, so the ratio C by D is coming out to be irrational. What does it imply? It implies that one of the number is irrational here. Understood? So either C is irrational or D is irrational. Clear?
Yes, ma'am.
Okay, so this implies either C or D, right? Or both, like both can be irrational also. Either C or D or both are irrational. So that is why we are getting pi as an irrational number. So I hope the contradiction you have understood. Clear?
Yes, ma'am.
Okay, now next is actually, a different topic. Only one question is there on the in the exercise. So we will do only one, right? Other you can practice yourself. So basically you have to show under root 9.3 on the number line. Now where does it lie? So it is easy to show 9.3 on the number line, right? That you can show. But what about under root 9.3? How will you show it? So basically you are plotting irrational number on number line. Is that clear?
Yes, ma'am.
So there are some steps of it. If you want, I think it's only one question, so we can write the steps also so that you remember later on. Let me first of all explain, then I'll write the steps. So first of all, like take a number line, right? You take a number line and like somewhere you have your 0, you have negative numbers are also there. But because my number is positive, so you don't have to draw a lot. Now 1, 2, 3, 4. I think I should draw. I think I should take smaller gaps, otherwise I'll not able to draw. So let me take 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and 11, and so on. 12 and something. Now the first step is, I'm writing the steps also. Now the first step is that you take a line segment, right? And you take the distance 9.3, like with whatever number is inside the square root. So you have 9.3 inside the square root. So you mark the distance 9.3. So it will be somewhere like here. Understood? When you have to do it on a graph paper actually. Use a graph paper for it. For this question, use a graph paper. So somewhere here you have your 9.3. So take this point as like mark it O, and this point you call it P. Clear? So basically OB distance is how much? 9.3. So mark a line segment OB is equal to 9.3 on number line. I'll show you the proof later on. First, you learn how to plot it. Right? First, we have marked the distance 9.3. Now you have to mark a point C, write down, then we will do that. Now mark a point C at a distance of 1 unit. Understood? 1 unit from B. 1 unit means, see, it is 9.3. If you add 1 to it, 9.3 plus 1 you are adding. So what should you get? Sorry, 1.0 like this. So 3, it will be 10.3. So if you take 1 unit distance, so it will be actually 10.3. Got it? So this point is your C. Is that clear to all of you? Yeah, nobody is responding.
Yes, ma'am.
Okay. 1 unit means, like for example, you are choosing a centimeter scale, right? So this distance will be 1 centimeter. If you are choosing an inch scale, so this distance will be 1 inch and like that. So that is called 1 unit. Right. Now third, what will you do is, now the actual line segment is now OC. Now you have to find the midpoint of OC. How will you find the midpoint? So we know by construction how to find the midpoint of any line. Like you take some distance in the compass, at least more than half of this line, right? And then you make a cut. Place your compass at C, right? Draw an arc here, if you people remember, right? Then with the same distance, place your compass here and then cut the arc. Is that okay? And then you join it. So the point you get here is actually the midpoint of this line. So you have to do actual construction with the help of product compass. Is that okay?
Yes.
Okay, so that's the midpoint T. Now what will you do it? You place your compass at D and take this distance OD in the compass and draw the semicircle. Like this. Clear? With D as the
Yes.
center, you have drawn a semicircle. Write the third point. Find the midpoint of OC. Right, and mark it D. Then fourth, draw a semicircle with like OC as sorry, with DC as radius. Clear? DC as radius and center D. So you take distance DC in the compass and then D is the center, draw a semicircle. So this much we have already done. Okay. Now you come back to your point B, right? This was your point B. Now what you have to do is, you have to draw a perpendicular on this line B again. How to draw perpendicular means 90-degree angle you have to construct. Is that okay?
Yes.
See, actually this much we suppose that you already know, that how to find the midpoint, how to draw the perpendicular. So the fifth point is, draw a perpendicular uh, draw a perpendicular on, sorry, at point B, right? Join this line, join this line with the semicircle. So draw a perpendicular. I'm not telling you how to draw a 90-degree angle. I suppose you all know. So you will construct a 90-degree line here, and then you will, with the help of a scale, you will join this line with the semicircle. Is that okay? Mark this point E. Mark it E right here. That mark it E. So this much we have done. Now you will take BE as the radius. Okay. Taking BE as the radius. Clear? Draw.
Yes.
Okay. Draw an arc. Draw an arc intersecting the number line at F. That means you have taken BE as the radius. Now place your compass here at B, right? With this distance, like BE, you make a cut somewhere here, right? On the number line. Let's say this is your cut. So you get a point here. Is that okay?
Yes.
So from B till this point, this distance is actually your under root 9.3 distance. So 7th, that means BF is under root 9.3. Please write it down. Just give me 1 minute. Yeah, has everybody written it?
Yes, ma'am.
Yes, ma'am.
Okay. So these are the steps to locate a point. So this is your point F. Please mark it F. So actually F is the location of under root 9.3. So from B to F is actually under root 9.3. Okay, let's go to question number 5 now. Do you people have some other book also apart from NCERT?
No.
Anybody? Right, okay. Now, next question is rationalize the denominator of the following. Now, what does it mean? Rationalization. First of all, understand this. Rationalization, I think we have already discussed it. So basically, rationalization has come from rational number. Like the name is coming from here, rational. So basically, whenever you have an irrational number in the denominator, for example, I have 1 upon under root 7, that kind of number. So I have an irrational number in denominator. So I try to convert this irrational number into a rational number. So this process is called rationalization. Okay. I can have numbers like this 1 upon 2 minus under root 3. because I know 2 minus under root 3 is irrational, right? Rational minus irrational is irrational. So again, I have an irrational number in the denominator. So if you want to solve this, so the first step is to rationalize the denominator. That means converting the denominator into a rational number. I hope it is clear. Let us see how we do it. First question. First part. First part is the same, 1 upon under root 7. So we do this under root 7, right? So we multiply numerator and denominator both by under root 7 in these kind of questions. So the numerator is 1 into under root 7, that means under root 7. And under root 7 into under root 7 is 7.
49.
Okay, so first of all, you will get something like this, 7 into 7. Is that clear?
Yes.
Okay, so under root 7 divided by under root 49, and under root 49 is actually 7. Is that okay?
Yes.
Yeah. So you can add these two steps, or otherwise you know that under root 7 into under root 7. Okay, just write it like this, no problem. Is that okay?
Yes.
So now you have seen that we have converted the denominator into a rational number. So this process is called rationalization. Second, we see how to do it. 1 upon under root 7 minus under root 6. Okay, so now I have both square roots. Now whenever you have denominator plus or minus, so what we do is we take the opposite sign and then we multiply with under root 7 plus under root 6 divided by under root 7 plus under root 6. Is there any problem? You can put it in the bracket, because something same number upon same number, it will actually cancel out and give you 1, right? So I can do it, right? For example, 2 by 2, ultimately I get 1. So if I multiply something by 2 by 2, doesn't matter, isn't it?
Yes.
Okay. Now why I'm taking the opposite sign? Because now can you see this is looking like a minus b and this is looking like a plus b?
Yes.
So that I can write it as a square minus b square. So you see like square root will be gone now. So ultimately my number will be without square root. So that is why we take opposite sign. So in the numerator, I simply have under root 7 plus under root 6, and denominator I can write under root 7 whole square and minus under root 6 whole square. So you have to remember this identity always. So a square minus b square. So that means under root 7 plus under root 6 divided by, now root 7 into root 7 is actually 7 minus root 6 into root 6 is actually 6. So you get under root 7 plus under root 6 divided by 1, which is actually under root 7 plus under root 6. That's the answer. Yeah, is that clear?
Yes, ma'am.
Third part. 1 upon under root 5 and plus under root 2. So same, you multiply with the opposite sign. Under root 5 plus under root 2, put it in a bracket, into under root 5 minus under root 2 divided by under root 5 minus under root 2, right? So numerator will be root 5 minus root 2 and denominator will be a square minus b square. So root 5 whole square minus root 2 whole square. So that gives you root 5 minus root 2 divided by root 5, 5 minus root 2 into root 2 is 2. So root 5 minus root 2 divided by 3. So that's the answer. Now you cannot do anything, leave it here. So in these kind of questions, like both were the square root kind of number in the denominator. Now in the fourth question, fourth part, you have under root 7 minus under root 2. So one number square root, another without square root. Here also you will do the same thing. So under root 7 minus 2, right, into under root 7 plus 2 divided by under root 7 plus 2, right? So that becomes under root 7 plus 2 in the numerator divided by, again it is a minus b into a plus b, that becomes a square minus b square. So under root 7 whole square minus 2 whole square, right, this time. So under root 7 plus 2 divided by root 7 into root 7 is actually 7 minus, this is 2 into 2, that is 4. So root 7 plus 2 divided by 7 minus 4 is 3. That's the answer. Okay, let us quickly move towards the next exercise also, that is based upon law of exponents. So exponent means when you have something in power, right? So far, there was no power involved. Now there are some laws. We will do questions, then you will get familiar with it, but first write them down. If you have two numbers like this, a to the power m, right, into a to the power n. So answer is actually when the base number is same and powers are different. So the powers actually get added up. It is m plus n. For example, you have 2 to the power 5 multiplied by 2 to the power 3. That clear? So this you can write 2 to the power 5 plus 3. That means 2 to the power 8. I mean, you can give one example of it. Then second, if you have a number whose power is m, then one more power is there. So in such cases, it will be m into n. So powers get multiplied. For example, I have 3 to the power, let's say 2, and then outside I have 4, right? So this will become 3 to the power 2 into 4. So again, 3 to the power 8 is the answer. Third law is, so now division, so multiplication we have seen. Now for example, I have a to the power m divided by a to the power n. Number is same, but only the powers are different in numerator and denominator. So it will be a to the power m minus of n. Clear? Let me give one example. For example, I have 2 to the power 5 divided by 2 to the power 3, right? So this can be written as 2 to the power 5 minus 3. So 2 to the power 2, which you can solve also. 2 to the power 2 is actually 4.
Ma'am,
Yes.
why do we have to subtract it like m minus n?
Yeah, this is the law. Okay, now why subtraction? See, for example, I have this 2 to the power 5 as I have taken divided by 2 to the power 3, right? So 2 to the
Yes.
power 5 means 2 is multiplied 5 times. Oh, sorry. Right?
Yes.
And then you have 2 into 2 into 2.
Yes.
So basically 3 2 will get cancelled out. So you are only left with 2 to the power 2. And what is this 2? 2 is actually 5 minus 3 that you can see. So it's a law. I mean, it will come out like this. It's a law.
Okay.
Like if you expand it, so the rest of the numbers will get cancelled out. So you only left with the difference of these powers, 2 to the power 3. Sorry, 3 will cancel out, so only 2 powers will remain. So that is why it is called law, like always it will happen, okay?
Okay.
Fourth, a to the power m, let's say you have different number whose powers are same. Numbers are different, but powers are same. So in that case, you can multiply the numbers together and then you can write the power outside. Clear? Let's take one example. Let's say I have 4 to the power 3 and into another number, let's say 2 to the power 3. So numbers are different, powers are same. So this can be written as 4 into 2 to the power 3, which can be written as 8 to the power 3. Yes, is that okay?
Yes, ma'am.
Let us look at the exercise also quickly. Exercise 1.6, that's the last exercise of this chapter. So find, right? First question, first part, 64 to the power half. Okay. Now 64 can be written as, you prime factorize it in case you're not able to understand it. You do 64. So 2 into 3 and 2, right? So 2 into 1 and 6, then 2 into 8, 2 into 4, 2 into 2, 2 into 1. So 2 to the power 6, right? And into 1 by 2. Now use the second law. So it will be multiplied. So 2 into 6 into half, right? Is that clear? So this is
Yes.
equal to 2 into, so this will be like, 3. Is that okay? Like 6 into 1 by 2 means 3 into 1, that is 3. And this will be 2 into 3 means 2 into 2 into 2, that is 8. Clear? Second part, now 32 to the power 1 by 5. Again, you can see like this, 32, like see here, 32 is actually 2 to the power 5. And then you have 1 by 5. So powers will get multiplied. So 2, 5 into 1 by 5, right? 5, 5 will get cancelled out. So 2 to the power 1 only. That means 2. Yes, Jesslyn, you're not speaking anything. Is this clear?
Ma'am, I'm here.
Okay, like any problem?
No, ma'am.
Okay. So now you have 125 to the power 1 by 3. Again, you prime factorize it. So 125 means 5 into 2 and 5, then, sorry, 5 into 5, and then, so it can be written as 5 to the power 3. So 5 to the power 3, wait, so 5 to the power 3, and then outside you have 1 by 3. So again, the powers will get multiplied. So 3 into 1 by 3, right? 3, 3 cancel out. So 5 to the power 1 only, which is 5. Okay, quickly do the second question also. First part, you have 9 to the power 3 by 2, right? So how can you write 9? 9 can be written as 3 to the power 2, right? 3 into 3 is 9, and then 3 by 2. Again, the powers will get multiplied. So 2 into 3 by 2. 2 will get cancelled out. So 3 to the power 3. And what is the answer? 3 to the power 3. How much is 3 to the power 3?
9.
Oh, 3 into 3 is 9, and 9 into 3 is 27.
27.
Yeah, it's 3 times. So basically, this is 3 into 3 into 3. So answer is 27. Second, 32 to the power 2 by 5. So we have just seen that 32 can be written as 2 to the power 5 and then power 2 by 5. Now you multiply the powers. So this is 5 into 2 by 5, right? 5, 5 cancel out. So 2 to the power 2 only. That means 2 into 2. This is equal to 4. Clear? Okay. Third part, 16 to the power 3 by 4. So You can write 6. Now here is 16, right? 16 means 2 to the power 4. So 2 to the power 4 into 3 to the power 3 by 4. So powers will get multiplied. 2 into 4 into 3 by 4, right? 4 cancel out. So 2 to the power 3, and this is 2 into 2 into 2, which is actually equal to 8. You can do it this way also, like 16 can be written as 4 to the power 2 also, right? It's a perfect square. And then power 3 by 4. This also you can write. So that means 2 into 3 by 4, right? But I think you will again get 3 by 2 here. No. You will get stuck anyway. Do it like this, 2 to the power 4. I mean, you can solve it, but right now you don't know how to do it, so I'm skipping it. Next, fourth part. Now something about negative powers I have not told you. Let us discuss about negative powers. For example, I'm writing 2 to the power minus 5. What does that mean? It means 1 upon 2 to the power 5. Does everyone know this? When you know something 3 to the power minus 1, what does it mean? It means 1 upon 3. Is that clear?
Yes, ma'am.
Okay, so fourth part, let us see. This is 125 to the power minus 1 by 3, right? Now 125 is 5 cube. So 5 cube power minus 1 by 3. So again the powers are multiplied. So 5 into, so 3 into like minus 1 by 3, right? Put a bracket. So 3 cancel out. So only 5 to the power minus 1. So that means 1 upon 5 is the answer. Okay, let us do the third also. We will be done with the exercise. So simplify. Now you have numbers like this: 2 to the power 2 by 3 into 2 to the power 1 by 5. Now you look at the identity, first identity. You know, numbers are same, base number is same, only powers are different. And they're in multiplication. So what happened? The powers will get added up. So somewhere you will mention the identity that a to the power m into a to the power n is actually equal to a to the power m plus n. So if we use it, so it will become 2 to the power 2 by 3 plus 1 by 5. Is that clear? Right? So they are fractions. Whenever you are adding fraction, you take LCM. So 2 into, take LCM, 3 into 5 is 15. Now 3 into 5 and 5 into 2 is 10. Plus, now 5 into 3 is 15, 3 into 1 is 3. Does everyone has any problem in this step? You know, sometimes students just get confused. Please tell me, it's okay, I'll explain it. Yes.
Ma'am, can you explain once again? Sorry.
Okay. So let us do it separately here. 2 by 3 plus 1 by 5, right? How to add fractions. So first we take LCM. So whenever you add or subtract fraction, that's the only way to do it. So you take LCM 3 into 5. 15, both are prime numbers. Sorry, both both are prime numbers. So this is 15. Now we see that how many times this 15 is going in the table of 3. So I mean, you don't have to write it, but in your mind, you know that 3 into 5 is 15, right?
Yes.
So this 5 is actually multiplied with the numerator. So the numerator is actually 5 into 2, right?
Yes.
Plus. Now in the table of 5, this is actually 3 times, right? So this 3 will be multiplied with the numerator, 3 into 1. So you don't have to write this, but keep this in your mind, okay? So 3 times. So this step you have to write. So next it will be 10 plus 3 divided by 15, that is 13 by 15. So please check the answer. I think this answer will be given in the book.
Yes.
Okay. Now 7, right. Now how will you do it? First of all, you can write it like this, like 1 upon 3 to the power 3 can be written as 3 to the power minus 3. Any problem?
No.
Yes. If you want to take it in the numerator, the power will get negative. Now it is a to the power mn kind of number. So powers will be multiplied. So 3 into minus 3 into 7. So that means 3 to the power minus of 21, which you can again bring in the denominator and you can write 3 to the power 21 is the answer. Because it's very large power, so you don't have to multiply all the 3 together. You can leave it like this. Up to 2 power, 3 power, that you can multiply, otherwise leave it. Right? Okay, next 2 parts remaining. Now you have 11 to the power 1 by 2 divided by 11 to the power 1 by 4. So you go back to this identity number 3, that if you have a to the power m divided by a to the power n. So as I told you, the powers are going to get subtracted, right? The denominator power will get subtracted. So there is a condition like if m is greater than n, right? So this will be written as now 11 to the power. So 1 by 2 minus 1 by 4. Now just calculation you have to do again, take LCM. Now 2 and 4.
8.
No, 8 will not be the LCM. LCM we don't take like this. LCM we take like this. Whenever you have prime numbers, then only you directly multiply them. 4 is a multiple of 2, right? You have to take the least common multiple. Clear?
Yes.
LCM is least common multiple. So 2 into 1 and 2 into 2. Then again 2 into 1, 2 into 2. Sorry, 2 into 1. So till you get all 1, 1. So the LCM is 2 into 2, which is 4. So LCM is not 8. So LCM is 4. Now we know 2 times it will go in the table, right? 2 into
Yes.
2 is 4. So 2 into 1 minus. Now 1 time it will go. So 1 into 1. So this is 11. So 2 minus 1 divided by 4. So that is 11 to the power 1 by 4. Yeah, that's the answer. Okay, one more part remaining. Let us complete it. Now this is 7 to the power 1 by 2 into 8 to the power 1 by 2. So this is identity number 4 when powers are same but the base number is different. So you can multiply the base number together. So 7 into 8 and then you can write the power 1 by 2. Clear? Please mention the identity here. Then you do it. So this will be 7 into 8 is how much? 56 to the power 1 by 2, right?
Yes.
Now you can further simplify it. You see how much is 56. Let's see if we can do it. So 2 into 2 and then 2 into 8, right?
Yes.
2 into 1 and 4, then 2 into 7. No, I think it will not be written as like multiples of 2. So you leave it. Please check the answer. I think it will be this much only. Check the answer in the book, please.
It is 56 1 by 2.
Yeah, okay, leave it. Okay, now all of you are here in the class. Okay, Jaziba has left. See, I want you to practice some extra questions also apart from NCRT because NCRT has a very limited number of questions in it, right? So you don't get a very good practice of questions. If you can buy RD Sharma, Like, I'm not saying you have to buy, it's your choice. If you want to buy, you can buy. It has a lot of questions to practice. Or otherwise, you can practice like previous year's questions you can see from internet, right? At least practice some extra questions also apart from NCRT. Anyway, I will also be giving you one assignment. I have already sent you 2 assignments on the chapter. So who has completed that? Yes, Zeba. Zeba is not here. I think Zainab. What about the assignment, Zainab? Just Hmm.
Ma'am, I actually contacted the Learnivio office,
Hmm.
but they didn't send me anything, and on my portal, it's not there.
Okay, so you could have messaged them that it's not
I
there.
messaged them.
Okay, then I'll check it out. I'll send you on your WhatsApp. I'll get it from the office.
Okay. ma'am.
Jasleen, what about you? Have you got the assignment sheet? Yes, Jasleen. I'm not able to hear you, Jasleen. Okay, then anyway, just please note, today also, I mean tomorrow, one more assignment I'll send you based upon the rest of the exercises. And you have to complete all the assignment sheets. Okay, Jasleen. Fine, I'll contact the office why you people have not got it. So you have to do the assignments. And in the next class, first of all, I'll discuss the assignment. If you have any problem in any question, you can ask me. Otherwise, I'll proceed with the next chapter. So the assignment will be left. So it's up to you. If you really want to discuss it, please complete it on time, right? Oh,
Ma'am,
yes.
we will go chapter wise or the for the exam.
Yeah. Have you sent me the syllabus, Zainab?
Yes.
Yeah, you have sent me. I think initial chapters were there. Let
Yes.
me just check once again. Yeah, actually, had a look at it. No, I have not received your message, Sanab, about the syllabus. Yeah, okay, it's here. Sorry. The number system is there, right? That we
Yes.
have done.
Then we have coordinate geometry for
Coordinate
half yearly.
Okay, that we can do. Then linear equation in 2 variables. Lines and angles we have already done.
Yes.
And triangle is remaining. Okay.
Triangles.
So I think I'll start coordinate geometry then.
Okay.
Algebraic identities we will do later on. Okay, I'll just go through the syllabus. I'll plan accordingly.
Okay.
Okay. All right.
Thank you.
Okay, bye. Jasleen, you can also share your syllabus for the upcoming exam so that I